Our 900 amp hour battery bank works, but it's not finished. After your feedback, we realized there's a couple upgrades that are going to make it safer. We had planned to do more testing last week, but we were out of town supporting family. So today, we're going to tighten everything up.
If you didn't catch the first video, here's what we've got. 3 batteries totaling over 900 amp hours. We've got the positive running through a fuse, a switch, and a Lynx distributor. And on the negative side, we've got a battery shunt that monitors current. You know what? After spending 2 weekends in here, I think I'm going to move the propane tanks to give myself a little more room.
This is a little better. Got the baby propane in here to give me some hip room.
This is our home and we really need to minimize risk. And so our astute viewers pointed out a couple things that we can do to improve safety, and I'm going to make those changes today. One of the things pointed out is that we should have a Class T fuse here, and that we should use a switch that is a little more robust and rated for a little bit higher amperage. And yeah, we're going to make those changes today. To make this safe to work on, I have the main power disconnected, but I'm going to have to disconnect my battery bank here from this wiring to make these changes. Battery bank's disconnected, but for my next challenge, I've got to address something, which is that I made this setup with the wire links for a certain size component, and these components are a little bit bigger. I just want to say clearly that I'm thankful that our viewers pointed out the need for a safer fuse block here. Very thankful for that. Now, in addition to the difference in physical size, it's longer, so I'm going to have to change the cable run a little bit. The studs are actually a larger diameter, so ultimately I have to remake entirely fresh cable. So anyway, don't mind doing it. It's going to be safer if I do.
Well, this switch is not appropriate for where we had it in the system, but ultimately I think I can make use of it somewhere else as we build out a more complete system for this trailer for boondocking.
Installing the Class T fuse in here is the easy part. Refiguring my cable lengths is going to take a little bit longer, but well worth it. Right now, I've got a problem, which is that my new fuse holder goes further this way, and so I don't have enough length on my red battery cable. But this forces an interesting solution for me, which is that I can shorten the length of this by running the leads off the opposite ends of the battery that I had them set up before. So ultimately, I will have shorter runs in the end because my red is not long enough. Here, let me show you more simply. If I go black to black right here and red to red right here, essentially I can cut out probably at least 2 feet of cable. And that's a good improvement.
I have this roughly assembled. There's a few things to point out. Right now, got a little bit of an angle to make this work. And I just have to pay attention that it comes through the fuse holder straight because there's a cover that I have to set down. So otherwise, I've got a shorter red run and I'm happy that that's changed. And everything else seems like it's going to work like it was. So I didn't have to remake too many connections. Had to remake essentially one on the positive and one on the negative side. It's actually another situation in here that I want to take a look at, possibly fix. I've got coiled wire, and there's a couple reasons why you shouldn't do that. One is induction, but I don't think that's as big a problem here because it's not a huge coil. What that will do is it'll make essentially an electromagnet, and it can cause problems with sensitive electronics. I don't think I have enough coil to do that, but the downside to what I do have is coiled wire. If it builds up heat, it sort of amplifies the heat because you've got two hot wires next to each other. And so I don't like the way I've done that, and I think I can fix it as part of this little renovation we're doing here to make things better and safer in the battery area. When I'm done, I have the expectation that the angles of these wires coming out of the switch are going to look a little bit sloppy, but ultimately they have to be at a very specific angle to fit in the space that we have without sticking up too high or interfering with anything else. You'll just have to trust me on that one. Right about there. One of these improvements I'd really hope to make has worked out. If you'll notice here, I've got the red coming around and I'm going to connect it here in just a minute. It used to go all the way down to here, so shorten that substantially. The black, meanwhile, used to go from here all the way to there. Now I have it on this battery, essentially switching the batteries that the outgoing current are connected to. Good improvement, shorter runs of wire, essentially less risk of failure, etc. Before I put the new cover on my fuse holder, I'm going to check everything for tight carefully. That last one moved just a little bit. I'm glad I did that. All right. Big fuse covered. And there's the click. Coming in here for the moment of truth. Let's see what we got. What are you doing?
Every time you reconnect the batteries, the radio comes on blaring.
Oh, sorry. Yeah, we're, oh. So I was about to hit the switch if you want to be present for that.
Okay. The new one?
Yeah.
Ooh, fancy.
Let me back up so everybody can see it. Okay, ready? Good. Nothing happened. All right, I'm going to check with the meter and see what we've got going on.
I am going to keep cleaning in the house, kitchen, bathroom, all the things.
Perfect.
Yeah, seems like you might be having more fun than I am.
Maybe. It's great in here. The hunching over and the stuffing myself in.
Oh, yeah, no, but you have so much more room because we grilled, so you took apart the hitch.
Yeah, it did help. 13.54. Same current on both sides of the switch, and both sides of the fuse are good news. Let's see. So if I didn't say it before, the main reason why we want the big Class T fuse here is because if we have a massive short circuit event, these lithium batteries, fortunately and unfortunately, can push a lot of current really fast. What this does is prevent catastrophic failure. Now, the fuses we have over here are actually rated for the loads. This one that we've changed out now is more of a fail-safe. So ultimately, we still want the types of fuses that I used over here rated for each load, the inverter, the 12-volt panel, etc. I have to say, making progress on this battery wiring has inspired me to deal with this over here. Essentially, this is the extra wire going to the inverter. It used to have to run through the floor, underneath, and out to the battery box. Now it doesn't, because it goes to the Lynx distributor side by side. Basically, I need about a foot of wire here, and we've got 5 or 6. No reason not to tighten that up. This is the coil I'm expecting that we can reduce substantially. Mostly, I need to get this off the wall so I can get to the connections underneath. It should be pretty straightforward, but because of the confined spaces here, it may take me a little longer than you might think. If you're wondering why I'm ignoring this rat's nest over here, I'm not. I just have to get warmed up for it, and this is going to be a good warm-up exercise over here with the 1000-watt inverter. Okay. Got it unplugged. I'm going to disconnect it from the 12-volt power, and then it should be safe to work on.
Okay. Getting this flat on its back does make it easier. Got some set screws for the positive and negative DC. And simple as that, those are off. Replacements here are 4 AWG, same size. Ultimately, I wish they were just a hair shorter, but they're about 2 feet long and maybe a hair longer. That should work just fine. I have successfully disconnected and reconnected positive and negative wires here. It's just an Allen key. It's easy enough to do. I'm gonna go ahead and swing this back over and put it on the wall. And the last thing that's bothering me is this ground wire. It's stiff copper in a casing, and I'm thinking about disconnecting it, pulling the slack back through the floor, and then reconnecting it when I get it up in place. Finally warm enough with the sun coming around behind me here that I can actually take a layer off. It's been a bit chilly all day long. That's better.
If you can agree with me for just 1 second that we can't fix everything in one day, this is the amount of wire I've removed and replaced it with this, which is essentially going to connect up here, and we're down to 1 extra loop. Essentially, we've got 1 extra loop. So big improvement there. I don't have a big coil of wire that could, in theory, heat up and the insulation could melt. You know, any other problems could be caused by longer lengths of wire than we need. So it's an improvement. The improvements will be steady with this, let's put it that way, because there's a lot. Don't look over my shoulder, don't look over here. There's a lot of improvements to make. Connections made, fuses back in place. There's a communication wire here. Got to connect back up. Communication wire. Last thing to do is to plug this in. Looks like we're back up.
This is the excess I've eliminated from the system today without changing the function of anything.
I'm really glad I got this done. It should have been here the whole time. Now there's a couple things I'd like to address inside the trailer if I have enough light.
It's been a few weeks now since I found this fan not working, and I fixed it by making it full speed only. I took out the switch right here. So you can see it's working, but it's full speed only and it's really loud. When Shauna's working from home, she likes to use it for a little bit of ventilation, but at a much lower and quieter fan speed. So I think I've got a solution, and I'm gonna launch into that right now. This is the old style switch. Essentially it uses a resistor to slow down the fan speed. And this is the new style. So I have the idea that this switch will work, but I don't actually know how. So let's figure it out. The switch has two basic parts. It's got this little knob, which will go through the old hole, and that should be the easy part. The second part will be fitting the circuit board. To power this circuit board, we need to bring in a ground and a power wire, and then the other two screws are for the outgoing power and a ground. 3 of these wires are very easy. One of them's a little bit complicated. Let me show you. Right here, this is where incoming power goes to the circuit board that's already in the fan, and then to the fan motor. The difficult thing that I have to do is use this ground wire up here in the fan after it goes through this switch, because this switch turns off the fan motor when the lid closes, and I need that switch's action to control my ground wire to control the fan. I've never done this before, bear with me folks. Surprisingly easy. I added a Wago right here to be able to tie this blue wire into the ground going to the fan motor. Had to get the meter out because I was starting to think I should have power here. I've got all the wiring done, but something seems strange. It turns out I blew a fuse. See, it's lit. Well, with the fuse back in, we're going high speed. I'm gonna turn this off real quick before we do any damage. I'm glad it doesn't sound like that all the time. This actually didn't come apart the way I expected. There's a wagon wheel shaped piece of plastic broken off up in here. I think it's gonna work, but we should know that this may need to be replaced. Right now we've got high speed, no switch. Let me think about it for a minute. Well guys, it's gotten dark on me. It's been a heck of a week. I'm on call and it looks like I'm gonna have to pick up this work on another day. But thanks everybody for watching and we'll see you next week.